So here we have two sets, A and B. Both of them are non-zero and finite sets. We also have a relation R from A to B, which is defined as XRY if and only if X divides Y. We need to determine the domain and range of R as well as the inverse of the relation R. Okay, let us begin. So first we note down the two given sets. So here we have the set A, which is given by the elements 2, 3, 4, and 5. Next, we have the set B. Set B contains 4 elements. So here we have 3, 6, 7, and 10. Okay. Now, since we have a relation from A to B, what we can do here is we can find out the Cartesian product of A and B. Although that's not necessary, but this is going to definitely help us. So what is going to be the Cartesian product of A and B? This is simply going to be a set containing ordered pairs. Now here we have a relation R. Now what is the relation R? The R is defined. We'll have to first write down the relation. Now relation R is going to be a set containing the set of ordered pairs X comma Y, such that we have X belonging to the set A and Y belonging to the set B. And also there's a relationship between X and Y. Here we have X divides Y. X divides Y. So this is how we are going to define the relation R. That means we are going to pick up some specific values of X from the set A and some specific values of the set specific values of Y from the set B, such that X is going to divide Y. So for simplicity, so let's say if we take the X value to be 2, then we must take Y to be equals to 6. Because 2 is going to divide 6. So here we can say there is a relationship that exists between the elements X and Y. So here we can say 2 are 6. This is a valid relationship. Fine. Okay. Next, what we have. So if we pick up 2, what is the element from set B that we can pick up such that it divides that element? So that's going to be 10. So here we have 2 are 10. Fine. Next, we have from the set A, let's pick up 3. So if we pick up 3 from the set A, then we have to pick up an element from set B such that 3 divides that element. So we have the element 3. So we have 3 are 3. Next, we can pick up 3 from set A and 6 from the set B to get 3 are 6. Fine. There will be no such element which gets divided by 3. That means 7 and 10 are not divisible by 3. Next, if we take 4, now 4 is not going to divide any of the elements in the set B. So the element 4 is not going to form any relationship with any of the elements of the set B. Next, we pick up 5. So if we pick up 5, then 5 is going to divide 10. So that means 10 is the only element from set B that 5 is going to divide. So here we have obtained 1, 2, 3, 4, 5 relationship which satisfies the condition that X divides Y. So that means now our relation R, that is simply going to be the ordered pair. So 2 are 6, so it's simply going to become 2 comma 6. Then we have 2 comma 10. Next we have 3 comma 3. Next we have 3 comma 6, and then we have 5 comma 10. So this is going to be the relation R. So R contains 1, 2, 3, 4, 5 ordered pairs. Fine. Now that we have the relation R, what we can do here is we can immediately obtain its domain as well as range. So what is the domain of the relation R? All you have to do is pick up the first element from each of the ordered pair. So here we have the element 2. So here 2 is again repeating. We don't have to repeat the element. Then we have 3, and then we have 5. So the domain of the relation R consists of the elements 2, 3, and 5. Okay, next we need to find out the range. The range of the relation R. Range of the relation R, that is simply going to be the second element in each of the ordered pairs. So we have 6, 10, 3. So that will be 3, 6, and 10. So these are the elements that belong to the range of the relation R. Okay, so we'll also need to find out the inverse of the relation R. Now, inverse of the relation is simply going to be take the ordered pair of the relation R and then interchange the position of the elements in the ordered pair. So 2 comma 6, that's going to become 6 comma 2. Then 2 comma 10, that's going to become 10 comma 2. 3 comma 3, that's going to stay as 3 comma 3. Then we have 3 comma 6, so that will become 6 comma 3, and 5 comma 10, so that's going to be 10 comma 5. Okay, so we have obtained the relation, the inverse of the relation R. So we can find out its domain. The domain of R inverse is going to be the set containing the first element of each ordered pair. So that's going to be 3, 6, and 10. Because the domain of R inverse is simply equals to the range of the relation R. And the range of the inverse relation R, that's going to be the set containing the second element of R inverse, and that is also equals to the domain of the relation R. So that means our set are going to contain the elements 2, 3, and 5.